Hello U9s. In this screencast, we are going to go through what you will need to know for your exam next week. So a few things about the rubric. Everything that's going to be covered will be included on this rubric, and I'll remind you how this works. So you have your capabilities here. Each of these is something you need to be capable of. So sketching linear graphs, finding a line equation, solving problems involving 2 points, so that's distant, gradient, and midpoint, and using your calculator. Now, each column is how well you do each of those things. So, for example, sketching linear graphs, depending on how good you are at this skill, how hard you've worked, the further up the column you go. So we'll be going through each of these columns and explaining what that is. So there's a few files you'll need to be aware of, and I'll go through that, and I'll remind you of the exam format as well. So the exam is on, this is next Tuesday, and it's the CAT. It's going to be 5 minutes of reading time and then 40 minutes writing. Now, the first section is non-calculator, so you will not be permitted a calculator for section 1. Then you'll get another paper, so it's actually a separate paper, and it's exactly the same timing. You'll have 5 minutes to read it. There'll be 40 minutes writing, and for this one you'll actually get a calculator. You'll get to use your calculator, so make sure you bring it. The main difference between these two is that non-calculator tends to test routines and procedures, so how well you can do a certain thing. It might be find this line equation or find the midpoint between these 2 points. The calculator task is more application-based questions. There'll be a story or a narrative you have to figure out to get the key information. So it might be something like on the practice task, you know, you have 2 people living on a Melway grid and you have to figure out where the school is and figure out what distance someone has to walk, or the speed. Make sure you can work out speed, how speed, distance, and time relate, something like that. So we're looking at applications of what you've learned. So those are the 2 parts. Now, you were given a practice task for the calculator section. All of this part from here all the way here, you'll be allowed to use a calculator for. All of this is calculator enabled. And all of this is covered on the practice task. So if you have a look, if you go to the Year 9 page for maths, Year 9 seal page, go to resources. Now that practice task was given to you, that's just there, that's the one you received when I wasn't there. There's the rubric for you to download. Now I've uploaded the solutions for you to view. So you can go here, let's say you want to have a look at page 2, have a look at the file. There you are. So Alan and Sally will walk to route 13 kilometers. The coordinates of the new Goon home are 2, -4. Here are the solutions for you. So that's all 6 pages there. And that covers the calculator task. And there's the rubric, which you can access here, and you have a printed copy, and you should have a printed copy of that practice task as well. So all of this is covered by that practice task. The actual task will be very similar. It'll have 3 questions. They'll be application based. It will be a very similar style. There'll be different stories, but you'll be required to use the same sort of maths. So we can cut out all of this because we've covered that. So let's get rid of all of that. Now we're left with, let's rule a line now. Let's make that a bit neater. We're left with this section. This section's the non-calculator, so we're looking at things you can do without your calculator. All of this section here, that's non-calculator. Okay, so we've got determine line equation. So that's about how do you actually get a line equation, and then you've got sketch linear graphs, drawing a picture. So we're looking at 1, 2, 3, 4, 5 kind of skills here, and 1, 2, 3, 4, 5 skills in this column as well. I'm going to be hopping over to Wolfram Alpha at some points to show you some ways you can check answers, which are very useful. So I'll keep that open. You should have access to Wolfram Alpha. You should be able to access it, that's fine. Okay, so we'll start with determining line equations. The first indicator we have here is uses gradient and Y-intercept to write line equation. What does that mean? Well, if you're using the gradient and Y-intercept to write a line equation, the only thing you really need to know is the general equation for a line, which is y equals mx plus c. And you must remember that the m value there is gradient and the c value is the y-intercept. This will definitely be on your exam. You will definitely be asked to write the line equation and label the gradient and y-intercept. That's not a hint. This will be on your exam. Then you might be given a question where you're told the gradient and the y-intercept. So let's say a question told you what the gradient was and told you what the y-intercept was. It might want a line equation. So it might say, alright, with a gradient of -5 and a y-intercept of 2, what does the line equation look like? Well, you know that -5 is the gradient, so you know it's y equals -5x, and that's +2. A question might ask, it might say, with a gradient of -22/7 and a y-intercept of -38 on 5, what's the line equation? Well, you take the gradient, you have y equals -22/7x minus 38 on 5. So we're plugging those in to our line equation. I'll give you 2 more to try yourself. So give these a go. Try, let's say you're given a gradient of -8 and a y-intercept of 5 on 4. What would you do with that? And let's try a gradient of 62 and a y-intercept of -16. Okay, here's what you need to do now. Pause the video and write down those line equations before the answer pops up. Pause it now. Did you actually pause it? Well, I'll give you the answers now. So for this one, we have y equals -8x plus 5 on 4. And for this one, we have y equals 62x minus 16. That's what that skill's looking at. You'll be asked something very similar to this on your exam, if not that identical question. Next, we have, getting more complicated, we have calculates gradient and uses y-intercept to write line equation. What's this talking about? So we're getting a bit trickier. So a question might say a line has a rise of 3 units and a run of 4 units with a y-intercept of -10. Write the line equation. At this level, that's what a question is looking at. So it's asking you to recognize two things. It's not only asking you to recognize the line equation, it's asking you to remember that the gradient is equal to rise over run. So let's sub that in. A rise of 3 and a run of 4. Now that you've got the gradient and the y-intercept, you can write the line equation. So that's y equals 3/4 x minus 10. And that's your answer at that level. So I've calculated the gradient using rise and run, and I've been given the y-intercept. So let's try a very similar question. Let's change these units. So what I'm going to do is take this question and very simply rub that out, rub that out, rub that out. Let's say a line has a rise of -12 units, so it's actually going down, and a run of 5 units with a y-intercept of 6. Write the line equation. Pause the video, have a go, and then view the answer. I hope you pause the video. Let's have a go. So m is the rise over the run, which equals, well, we have a rise of -12 over a run of 5 units, and we can't simplify that fraction any further, so that's our gradient. Let's write our line equation, which is y equals mx plus c. Now we can sub in our gradient, which is -12 on 5x, and we can add 6, which is our y-intercept. There we are. Let's do one more. So we'll clear that away. Let's say we have, this time, we have, oh, that's being a bit tricky. Let's say this time we have a rise. Oh, let me get the pen back. Let's say we have, bother. Let's get out of that one. Oh, I see. Hang on. There we go. Let's say we have a rise that's equal to -4 and a run that's equal to 2 and a y-intercept of 6 on 5. Well, our line equation, we need to find the gradient first. The gradient is the rise on the run, which is -4 on 2. This time you would have to simplify, so that becomes -2. Finally, you can write the line equation and then substitute the gradient, -2x plus 6 on 5. Okay, so that's how we handle that problem. Let's keep going. So, oh, what's going on here? Let's just clear that. Okay, what's next? What do we have next? We have creates line equation using 2 integer coordinates to give integer answer. So this is what we're working on a lot. So we're given 2 points. Recall that if you have 2 points, you have a line that passes through them. So we're told to take the points. Let's say we have 6, -2 and 14. Let's do 14 and let's make that 14,4. Find the line that passes through them. So once again, This is all about our line equation. It's all about y equals mx plus c. But we've got a bit more work to do. The first thing to do is write the gradient formula. M is y2 minus y1 over x2 minus x1. So we'll call this x1, y1. We'll call this x2, y2. Okay, then we substitute. So you've got y2 minus y1. Watch for the signs. I'm minusing a negative quantity over x2 minus x1. 4 plus 2. That becomes 4 plus 2 because we're minusing a negative quantity. We have 4 plus 2 over 8, which is 6 on 8, which is 3/4. Now that you've got your gradient, you can take your gradient and sub it into the line equation. So you have y equals mx plus c. So subbing that in, we have y equals 3/4 x plus c. And now what happens is we need to choose a point. We can choose either one to solve for c. Let's choose this second one here. We have 4 equals 3/4 of 14 plus c. We have 4 equals 42 on 4 plus c. C equals 4 minus 42 on 4. So we need to simplify that. So 4 minus 21 on 2, which is the same as 8 on 2 minus 21 on 2, which equals negative 13 on 2. So our final answer is y equals the gradient's 3/4 minus 13 on 2. Now, I've been a bit of a cheat because that actually falls under the next task. See, it's 2.1.4 because I'm getting fractions. So if you're working with fractions, if you end up working with fractions, that's this harder one here, one of the hardest. So that's really 2.1.4. I'll jump back to this one. How am I going to check my answer? This is where I need to use Wolfram Alpha. So I've got 6, negative 2 and 14, 4. I go to Wolfram Alpha. I literally type in those points. 6, negative 2 space 14, 4. Let's see what it tells us. You can scroll down. It's going to work out a bunch of things. Okay, it tells us the distance between those points is 10. It tells us the midpoint. Aha, we have a line equation. So it tells us the distance, midpoint. Here's the line through those points. That's how important the line equation is. You just tell this math search engine, you give it 2 points, and it just spits out the line equation. Let's see, 3/4 of x. Yes, 3/4 of x minus 13 on 2. So that's how we know we've got the right answer. I'm going to show you another example where we get integers, whole numbers, and then I'll set you some problems to do yourself. And then that way, when you do the problems yourself, you can check your answer with Wolfram Alpha. So let's do a simpler one. Okay, so let's consider the points. Let's see, I need to come up with points that are going to give an integer answer. Let me think for a sec. Consider the points this and this. So let's take 15 and 10 there. So we have 15 and 10, and let's do 6 and 1. Okay, I've rigged that, so that should give us an integer answer. Find the line equation. Find the line equation that passes through these points. Passes through these points. Okay, how do we find this line equation? Well, we know that the gradient is the difference in y values over the difference in x values. So we've got x1, y1, x2, y2. Let's sub that in. We have y2 is 15, y1 is 10, x2 is 6, x1 is 1, 15 minus 10 is 5, 6 minus 1 is 5, 5 divided by 5 is 1. So our line equation, y equals mx plus c, becomes y equals 1x plus c, but we don't write ones before variables, so that becomes y equals x plus c. Now we choose a point. I'm going to choose this one, this point right here. Let's sub it in. 10 equals 1 plus c. Solving for c, we get c equals 9. Subtract 1 from both sides. And then y equals x plus 9. That is your final answer. Okay, how do I know that's right? I don't, so I need to check it on Wolfram Alpha. So I've got 1, 10 and 6, 15. 1, 10 and 6, 15. Let's see what we have here. It's doing its fancy loading. Points has the distance between them. 5 lots of root 2. There we are. X plus 9. There's the line through those 2 points. And if you were wondering the midpoint and the distance, well, it has that there for you too. Okay, that's all well and good, but you need some practice. So I'm going to make some problems. Let's say find the line that passes through. Let's come up with A, B, C, D. Now, you can check your answers on Wolfram Alpha, so you'll know if you've got it right or wrong. Let's make these ones come up with integer or whole number answers. So I'm going to have to rig those to come up with integers or whole numbers. I'm going to make these ones fractions, so they're going to be nasty. So the fractions ones are this harder skill here. The integer ones are this skill here. Let's see, I'm going to have the numbers 12 and 4, and then I want 4 and 2. Okay, so that should give you, let's see, what answer should that give you? 4x plus c. So that should give you y equals 4x minus 4, I think. Anyway, you can use Wolfram Alpha. I won't spoil it. Let's do something like -20, and we'll have here, we'll have 4, and then we'll have 9 and 1. That should give you, yes, that will give you integer solutions. Will it? Yes, it will. Okay, let's put some nasty ones here. Let's do one 3, 19, 7, and -6. So this will definitely not give you integer solutions. These two will give you something like y equals 5x plus 3 or something like that. This one will give you fractions. And let's do one that's just straight out fractions. This will definitely give you fractions. 6 on 7, and let's call it 10 thirds. Okay, you can check your answers with Wolfram Alpha. I'll show you how to check it for fractions. So we've got half, -5 thirds, 6 on 7, 10 on 3. So let's do that. So we have a half, negative 5/3, 6 on 7, 10 on 3. 10 on 3. So you just put, if you want to divide, you just put the slash there. So we have the slash through there. Loading, loading, loading. And it will give you an answer. There you are, 14x minus 26 on 3 is the line that passes through those 2 points. Okay, last but not least for this determined line equation, I'm going to have to make this 2 parts or else it's just too long. 2.1.5, analyze parallel and perpendicular statements about lines to determine line equations. So I'll remind you, we did this last year and some of you are doing it on your pathways. I'll remind you really quickly that if you have 2 lines and they're perpendicular, like this, they're perpendicular, then let's say the gradient of this one is 3/4. To get the gradient of the other one, you flip it and make it negative. You flip the fraction and flip the sign. So this becomes negative 4 on 3. This isn't for everyone, this question. This is for if you're up to it in pathways or you're ready to tackle this skill. If they're parallel lines, let's have a look-see. So if we have parallel lines, this is just a reminder. Parallel lines have the same gradient. So for example, if this is a gradient of 2, this is a gradient of 2 as well. So a question might say something like this. I'll clear that, I'll make a question. This is the last question on the paper and it's easily the toughest. I'll give you a taste. I might say a line is formed by joining 1, 2 and 3, 8. A line perpendicular to the first line formed passes through 0,3/4. Find the second line equation. This is tricky. Okay, I'll draw you a picture of what's happening. So a line is formed by joining 2 points. So you have 2 random points and a line's formed by joining them. There's a line perpendicular to that passes through the y-intercept of 3/4. So we want this line equation. That's a sketch of what's happening. I'll show you how to solve the problem. Once again, this is the tricky problem on the paper. How do you do this? Well, we need to find the gradient of the first line. Let's call it M1 because it's the first line. The gradient's y2 minus y1 over x2 minus x1. So we have 8 minus 2 over 3 minus 1, which is 6 on 2, which is 3. Okay, the gradient of the first line is 3. We know that the second line's perpendicular, so the gradient of the second line is going to be negative 1/3 because it's the negative reciprocal. Now, we want the gradient of the second line. Let's call it y sub 2. Sorry, we want the line equation. Well, we know that y sub 2 has gradient negative 1/3 x plus c. But we also know its y-intercept here is 3/4. So we can take its y-intercept and sub it right in. y2 is negative a third x plus 3/4. And that right there is your answer. So it's not really about the math skills, it's more about like interpreting the question and figuring out what the question actually wants, because it'll have words like perpendicular. You need to recognize that perpendicular means flip the fraction over and flip the sign. So that's the sort of thing it could ask you there. I'll give you one more problem to figure out yourselves to have a go at. It might say, this is for 2.1.5, it might say something like a line is parallel to y equals 3x minus 15, and it also passes through the point 7, negative 8. Find the line equation. That's something you can have a go at yourself. If you can track me down, I would be more than happy to give you the answer. So we'll call this part 1, looking at determining line equations. In part 2, what we'll look at is this column here, which is sketching linear graphs. And if you have been, thank you for watching.